Welcome, everybody. Thanks so much for joining us today on this office hour session on finding and testing your critical dependencies. Some quick notes before we get started. This is an interactive webinar. We want to hear from you as much as you want to hear from us. So again, if you have any questions, you can enter them into the Q&A panel, or just open up the chat and say hi. Let us know where you're watching from, where you're calling from, and what you'd like to get out of the session. This webinar will be recorded and the recording will be made available afterwards. So if you missed part of it, don't worry, we'll be able to send that to you. And if you're new to office hours, welcome. This is a monthly session that we do. If you're interested, we have sign-up links at gremlin.com/office hours where you can see all of our past and future sessions and sign up for them is free as well. And just to introduce myself, I'm Andre Newman, Senior Reliability Specialist, and I'm joined by Jonathan Sabo, Senior Solutions Architect, both of us here at Gremlin. Again, we're here to answer your questions, so we're more than happy to answer any questions that you might have. So a quick look at our agenda. I'll start with a short presentation introducing the concept of dependencies and how they work in Gremlin. I'll take a look at how Gremlin finds and shows them. We'll talk a bit about the test that Gremlin provides to help you build your resilience against dependency failures. John will show you a quick demo about how this works in practice, and we will end with Q&A. So quick question. How do you track your dependencies? This is one of those things where you'll probably get like a dozen different answers from a dozen different people on how they do it. Maybe you do it by hand using spreadsheets, using a dependency tracking tool like maybe SolarWinds or Dynatrace, or you don't track dependencies. That's totally fine too. Or might use a different method. We're just interested in knowing how you do this and where you found success, or maybe where you've run into some stumbling blocks. So definitely let us know if you're up for it. So I always like to set some sort of goals for the different sessions. So coming up with some for today, we want to create a list of dependencies belonging to each of our services, right? We have a service, we want to know what dependencies it's communicating with and what it's relying on. That's kind of like the very first step in this. Second is being able to test whether that service can tolerate slow or failed dependencies, right? If your dependencies go down, how does that impact your service, or does it impact your service? Doing things like testing for expiring TLS certificates, right? It's not just that your dependencies can fail, they can also have these certificate expiration issues that can cause all sorts of other problems. Google Slides is being a bit slow. All right. And then being able to automate this process so you can find regressions and make sure that you haven't introduced any issues, or rather that any new dependencies you've added aren't going to fail either. So at the same time, we want to know what your goals are for coming to this session, what you're interested in learning. So highly encourage you to sort of share your experiences and share your thoughts and let us know. All right, so jumping into it, this slide is mostly for level setting. Chances are if you're here, you already know what dependency is, but still, this is just to get us all on the same base. Essentially, a dependency is any independent service that adds features or functionality to a different service. For example, if you've ever used Amazon S3 or any one of their other 5,000 services, if you have a database running behind a web server, or if you use a memory cache like Redis, these are all databases, or rather, sorry, these are all dependencies. And these can be other services run by teams in your organization. They could be externally hosted services like cloud providers, and even your own dependencies, or your own services rather, can be dependencies of other services. And that's really when reliability becomes important, is when somebody is knocking on your door or pinging you on Slack asking why your service is down and why it brought theirs down. And so what you end up with is a chart kind of like this with all these different services and the interconnections between them. Now, the problem is that as we outsource more and more functionality to dependencies, especially with the massive cloud migrations that people have made over the past 20 years or so, our application architectures become more and more confusing, right? These are super complex, gigantic, interconnected models that our brains are simply incapable of keeping up with. And even these pictures from Amazon and Netflix are a few years old. By now, they're probably much more crazy and much bigger. And so really, we need a system to track these things for us, and also ensure that if any one of these millions of connections fails, we don't have a cascading effect where the rest of our applications fail as well. And that's really what we're trying to focus on with dependencies in Gremlin. So speaking of, when we talk about tracking dependencies in Gremlin, there are kind of three key concepts we need to consider. First are your services. Gremlin associates dependencies with your services. So the first step is defining those services. either manually or by letting us detect them automatically for you. Second is once you have your services set up, Gremlin's able to automatically detect the dependencies that your service talks to. And we do this by checking DNS queries, but also connections that are made through the network. And of course, you can manually add dependencies too in case Gremlin misses one, or you have one that you use less frequently, but still rely on all the same. And with these two in hand, Gremlin's able to automatically create tests that you can then run. These include latency tests, failure tests, and those TLS expiration tests that I mentioned earlier, again, to make sure that your service keeps functioning even if one of those dependencies fail. And one important note I want to make that I'll probably make again throughout this is that when we run a dependency test in Gremlin, we're not actually testing the dependency, we're testing the service that relies on the dependency. This is where the agent is running, this is where the latency gets injected. And the reason for that is it's the service that experiences the issue when the dependency fails. And you might not actually own the dependency. It could be owned by a different company or a different team. So you can't really test that yourself, but what you can do is make sure that the connection between your service and your dependency is as resilient as possible. And so that's the approach that we're focusing on here. And so what this looks like in practice, in Gremlin, you go in, you start with your services. These are host containers or Kubernetes resources that you've deployed yourself that perform a specific function. When you add a service, Gremlin automatically creates a set of tests for it. But again, it uses that DNS traffic to find out which other services or which other endpoints your service is talking to. And that's how it creates those dependencies. And if you kind of squint your eyes really closely, you can just about see one of these at the bottom of the screenshot. Next, Gremlin finds those dependencies. This is kind of what it looks like in the product. You also see it as John goes through and kind of walks you through it. But essentially, you have a list of host names or IP addresses that you're able to look through and also run tests on. So if you click into, in this case, the dependencies icon, it'll bring you to a page, or the dependencies link rather. It'll bring you to a page where you have all of your different tests listed for all your different dependencies, and you're able to go through and run those tests. And this is also the screen where you would go in and manually add any dependencies that weren't detected automatically. And speaking of, as soon as the dependency gets added, you can go into Gremlin and start testing it. Again, you're not running these tests on the dependency, you're running them on the service that it belongs to. So for example, let's say you have a service called the Ledger Writer that stores data in Amazon S3, and you want to make sure the service can keep running even if S3 goes down at some point. You can come in here, you can run this failure test. It drops all network traffic from the service to the dependency, so to S3. And while it's running those tests, it's performing health checks in the background to make sure your service is still up and running. So essentially, this is how it runs these dependency tests. It's monitoring your service itself to make sure that it can keep running even if one of its dependencies go down. And of course, if you're just setting this up yourself, if you're just getting started, you can't really expect the functionality to stay consistent if a dependency fails. So what this test is really accomplishing is making sure that any fail safes that you have in place, any fallbacks that you use, let's say maybe you have data replicated from S3 to someplace else or in a different zone, and you want to make sure your service can fall back to that zone. This is the perfect type of test to use for that. It's ensuring, again, that your service can continue operating and stay stable, even if a dependency isn't. And just taking one other look about how it works in detail. First, you start with your service, right? This is the part of the application that you want to make more reliable. This is also where Gremlin is installed, our agent, which is why I have the Gremlin icon there. From there, Gremlin looks at DNS queries and network traffic that the service is making to identify its dependencies. These can include databases, Python scripts, web servers, any other similar network endpoint that performs some function like this. And if Gremlin notices a lot of connections to a particular service, that's when it identifies it as a dependency. Yeah, that's when it identifies it as a dependency. Essentially, the more connections that are made, the more confident Gremlin is that this dependency is legitimate and not just a one-off or something that is just kind of expected, like if you're communicating with a network time protocol or some other service that pretty much every service depends on. We won't surface those, but we will surface the ones that you communicate with frequently. Now, one good thing about this is that because this process is DNS-based, we can actually track dependencies by their host name. So even if these dependencies have a dynamic IP address, or rather there are multiple IP addresses behind them, like if they point to a gateway or something, this will still work all the same. So you don't have to worry about going in and constantly keeping this updated. And again, you can always manually add or remove dependencies if you want to. Now, one sort of side effect of this that's still really useful is that this helps find hidden dependencies or dependencies that you might not have known about or forgot about or never got around to documenting, or an engineer deployed it and then left the company, so that knowledge is gone. For whatever reason it might be, dependencies can fall by the wayside. So having a tool like this that can actually go out and find those for you and surface them automatically, and then also test them to make sure that they're reliable, or at least they can fail reliably, is super helpful and a nice bonus to this functionality. And also, as a side fun fact, when our engineering team was trying this feature out while we were developing it, we actually found some of our own hidden dependencies lurking around. So we were able to go in and address those, either remove them if we weren't using them, or just work them into our reliability testing to make sure that we were reliable to them. So in a sense, you'll be surprised at what you find, and you'll never know if you run into a dependency that you just had no clue was there before. All right, so I spent a whole bunch of time talking. I'm going to turn it over to John now, who's going to show us a quick demo of how this works in practice.
Hey, thank you very much. Let me see if I can share my screen. 1 second here. All right, cool. All right. So what we'll do today is we'll walk through services and the automated dependency discovery, and we'll take a look at 3 different applications. We'll look at Kubernetes hosted in a couple of different clouds. We'll look at the storefront application, the hipster shop, aka open telemetry demo. A lot of people are probably familiar with. It's a great example of a containerized microservices app with a bunch of different dependencies. The call graph goes across a bunch of different pods that can be spread across different nodes and different availability zones, which makes understanding the dependencies, the call graph, and what happens when one of the services can't communicate to another service. How does it behave? Does it show an exception? Does it show a 503, or does it just keep humming along and happily continue working? And then we have also WordPress as well. I have set up to kind of show some single points of failure for people who store their state in the cloud. So just kind of to start, when you start using Gremlin, you install our agents, whether that's on Linux VMs or Windows VMs, or in this case, Kubernetes clusters. And what I wanted to highlight was kind of how do you onboard your applications and your infrastructure to take advantage of Gremlin's dependency discovery. The first part of that is creating services. And you can create services manually, targeting hosts, containers, or Kubernetes workloads. In this case, we're targeting the hosts that make up the Kubernetes cluster. And I just wanted to highlight the fact that the infrastructure have dependencies too, not just the applications that run on top of them. And so it's also important to test this part of the dependencies. What happens to the Kubernetes cluster when it can't talk to its registries that it pulls container images from, or any of the other third-party or APIs that might be part of the cluster? Does the cluster fate share with any of these dependencies? Allowing you, so what Gremlin will do is surface these and allow you to run tests across these. So that was a little bit about services manually created for the infrastructure, and then showing you how the dependencies will be discovered over time. All you have to do is create a service and then let Gremlin run for a little while, probably a half an hour or so. And as Andre was saying, we monitor the DNS lookups and then also the socket connections to those DNS names. And we'll surface those in the form of the dependencies. If you find yourself with a dependency that you don't care about, you can delete it. It won't come back. If you recreate the service, you see them come back again. I'm going to show, so what I've done is I have these Kubernetes clusters added, and I have shared a couple of the namespaces with some of the teams that test the reliability of the applications running on the cluster. I've got like a WordPress performance team and a storefront performance team. And as a platform engineer, I've shared those namespaces with those teams. And if you're in those teams, you can do experiments and create services that automate this testing, what I'll show here in just a moment. So what I'll do now is I'm going to switch from the platform team over to a storefront team. We'll take a look at the services inside of the storefront team. You'll see that there are a number of different services. And I'll just show you how one of the ways that these can be created for you automatically. Again, you can come in and you can manually click the services, select the Kubernetes workloads, but if you happen to have deployments in your namespaces or in your namespace, or you have stateful sets, so deployment stateful sets, you can annotate those deployments or the stateful sets, and then Gremlin will automatically create those services and then start doing the dependencies discovery for you automatically without you having to do anything. I've already done this. And one of the other things you can do is you can actually share the services. So you can create them in one team and then share them with another team. So these are actually created by me and the platform team, and I'm sharing them with the storefront team. Now, just by adding these annotations, that doesn't automatically create the service in the team. You still have to share the namespace with the team in order to give them access to those workloads and to be able to run these experiments. But after doing that and then waiting a little bit, probably 15 or so minutes, you'll start to see these services show up here inside of your Gremlin account. Every team inside of Gremlin can be assigned a test suite. In my demo environment, I have cloned the Gremlin recommended test and kind of modified the baseline test for my usage, for my demos and for my experimentation to the Sabo.io baseline tests. And what this lets me do is test automatically in the whole company against a set of, a baseline set of tests, and then I get a score, and I can compare across the teams to see, hey, am I more reliable over time? Am I more reliable than this other team? Just adds a bit of accountability and lets you visualize and track the reliability of your services. So this microservice, I think Andre shared a diagram of it a little bit earlier, but what I will do is let's use it. Let's use this application. This is the open telemetry demo. We're going to shop for some telescopes. And so what I'm doing is just adding in different stuff I want to buy and placing my orders, and I'm going to continue shopping. And I'm going to go shopping again, buy some more telescopes, add another telescope, and then we'll place that order. While that's happening, what we can do is we can look at the different microservices. We'll pick the cart service and we'll say, hey, what are the traces coming from the cart service? And this will show us the call graph of the cart service. And we'll see, hey, what are the different pieces of this microservices application that are being hit when I'm buying my telescopes? If I take a look at, like, you can see them all listed here. The cart service front end. Here we go. Front end ingress. We'll pick something a little more interesting. So when I connect to this application, the front end proxy, this is the front door to the application. And you can see that when you make a connection and you're connecting to the storefront, it's involving not just the front end service, but also the checkout service, the shipping service, the quote service, the email service. And so what you want to do is make sure that, hey, that when I go to my storefront, that if there's a problem with like the email service, that the main user interface doesn't show an error, or at least you know what happens when you can't talk to the email service. Does the front end service fate share with the email service or the cart service? Knowing that and figuring that out ahead of time lets you manage that either in code or infrastructure changes, or just in general, just to have in notes. And so we can see here that the cart service makes calls to lots of different workloads behind it. Let me and so does the checkout service. Let's look at that one too. Let's see. So by simply creating the annotation to your workloads, letting Gremlin run for a little while, it'll surface all of the dependencies from behind that particular microservice. So, and then because we've assigned the service a test suite, we have the ability to test for scalability, the CPU, memory, the zone, host, DNS redundancy. And you can see that this particular application has a failed test. And you can see that we've got 9 dependencies that are here. Some of the dependencies haven't been run yet, and then a few of them have. And as you run more tests, you can increase your reliability score. If you look at one of you can drill into the dependencies, and you have the ability to delete. You can edit them, and you can mark them as a single point of failure. I'm going to switch over to another application. Let's take a look at the WordPress app. So if any of you have ever set up WordPress and Kubernetes, you can deploy it all like entirely to Kubernetes. And that's what I've done for the dev environment. So you've got a pod that represents the front end, the memcached, and then also the database. But Kubernetes workloads are ephemeral. So when I kill that database pod, all my data goes away. And so it's not suitable for production workloads unless you just don't care what happens to your data. And what most people will do is they'll take the state, either they'll deploy it in a highly available manner inside of their Kubernetes cluster, or if they're in a cloud, they have the ability to just use like a cloud service like RDS or the Azure databases or the Google databases. And then you don't have to worry about it. You just point your Kubernetes workloads, the stateless portion of the workloads, the web app, memory, maybe the in-memory database you use for caching inside of Kubernetes, but then you have the state stored outside inside of the cloud, and you just make use of that. So if I look at my dev WordPress and I come down, it hasn't noticed any of the dependencies yet because there's only a single pod running in this workload. I only have one WordPress pod. In order for us to be able to like provide you with highly valid valid dependencies, we require that you have at least a replica set of two. So you need to scale your replica sets beyond a single pod. If you're deploying this on VMs, you want to have two VMs as part of that service, and then you'll start to see the dependencies being automatically discovered. Another nuance to how this works is if you have like really old Java applications that do DNS lookups once when they start up and then never again for the life of the workload, after 30 or so days, if we don't see any activity at all, Gremlin will remove them. And so if you have a critical dependency that you want to make sure is captured, it's probably best practice to go ahead and take the automatically discovered one and to create a manually created one so it's there forever if there's not like ongoing communication over the course of 30 days. If we take a look at the WordPress prod and we scroll down, you'll see, hey, I do have a dependency, and you've got a little mark over here. This dependency was marked as a single point of failure dependency. This setting is configurable on the dependency page. So when you use Gremlin's reliability management, you can come here and just click run all and then manually run against the test suite. These can also be scheduled to run on a schedule. If I wanted to run them every Monday at 12, but we don't want to cause an outage every Monday at 12, right? We don't want to disconnect the ability for the WordPress app to talk to the RDS database if there's only one, if it's a single point of failure. By denoting it as a single point of failure, if you come in and you edit it and you select, hey, mark this as a single point of failure, the automated reliability test won't run against this particular dependency. But that doesn't mean you can't test this too. But it's probably a better idea to do this when you have people in the office as part of a game day. For example, hey, I want to see what happens when we fail over from one database region to another. Maybe that's something that you do manually. So this a little bit about some of the nuances of Gremlin dependency discovery, how they work, just making you aware that you can apply this to the physical infrastructure that hosts your applications, the applications themselves, and then also how some of the safety features around critical dependencies for third-party services and cloud services. Let's see if there's any questions.
Looks like we had a couple come up in chat. First one was does dependency auto discovery work with the Gremlin sidecar that's used for failure flags? And
Not yet, coming soon. Over the next, we'll be integrating failure flags further into RM. And then when that happens, that will be in the next couple of months or so. That will be one of the capabilities probably. Another one is how to create services automatically. Yeah, I'm not sure if you caught that at the very beginning, but if you've got tons of services, hundreds of services in different namespaces, really easy. You can create, all you have to do is create an annotation on the deployment or I'm not sharing my screen anymore. Sorry. I was over here and then I'm back over here. So for example, in the example of the storefront application, there's a bunch of different deployments here. And what I've done is I've annotated them with the service ID, and then I can give it a name that I like. That's gonna make that show up as a service inside of this particular team. When you do this, you have the ability to give it a team ID if you're sharing this, if you're creating these services on behalf of some other performance team or another QA team that's going to test these. You can put them in a particular team ID by using that here with the team ID. And then this will automatically do it. And you can create simple little scripts to automate this further. Let me see. What's the next question?
It was just me. I just dropped a link to the annotation instructions in our docs.
Here it says, in order to use the services, does Gremlin agent need to be configured to collect system metrics? How and where? No, it does not. Gremlin will observe the DNS lookups and the socket connections made by your services as you configured, and that'll happen completely automatically. If you want to, we do integrate with observability platforms as part of health checks, but that's a different office hours. I guess there's another question. Does it also require setting up permissions access? No, as soon as if you have access to a Gremlin team and you can create services, the moment you do that, the Gremlin will start monitoring your service, and over probably like 30 minutes or so, it'll start surfacing the dependencies that it sees. But again, it has to happen in order for Gremlin to surface those dependencies, you want to have a replica set of two, you want to have two VMs behind the service, so you'll be able to take advantage of the automated discovery, or you could just create them manually if you already know what they are.
And one thing to add on the question about collecting system metrics, we get that a lot of companies who use Gremlin are really concerned about security. And so we really designed this from the ground up to require as little access to these systems as possible and collect as little data as possible. So to that end, we have a full page in our documentation just dedicated to exactly what the agent does. I'll post it into the chat in a second. But if you're ever wondering, how does Gremlin do this? Is it collecting information? The short answer is no. The long answer is we outline all of this in the documentation. So if you want to check it out, or if you have a security team that it wants to know more about this software, you can just send them here and this will cover everything. We have any more questions?
So we have another one. What is the overhead of running Gremlin agent in Kubernetes? It's very minimal. And if you look at it, actually, there is a docs page that covers some of that too, that shows you how you can look and check on your own. Let me see if I can find that really quickly.
Okay, here we go. Let's see. Yeah, it's very minimal.
Well, the client overhead on the compatibility page.
Okay.
Yeah,
Okay. Yeah, it's a much better link. My mistake. Yeah, ignore me.
Yeah, I'll paste it in here. If you scroll all the way down to the bottom of the getting started compatibility, and you go down, you'll see that we did some tests on Linux and Windows, and it's negligible. But if you're concerned about that, we encourage you, go ahead, spin up a test, and you can see exactly how we came to the same results that we post on our compatibility page.
Yeah. And for Kubernetes, there's just one instance of the agent running on each host. So it's not like we have separate agents running for each container or something. It's just one per host. Oh, really good questions.
I guess I'll just close with like an anecdote. We were just working with another team, and prior to using Gremlin, they were in order to test, to enumerate the dependencies, to see the services, and then to test, hey, what happens when I shut one of these off and they can't communicate with each other? Everyone had to have access. They had to be able to SSH into these servers, and they had to be able to turn them off. And so it can be very difficult, especially trying to collaborate with different teams. But from a security standpoint, all you have to do is get Gremlin installed as an agent, and then as you saw, it's very easy to automate, and it makes it really easy to share with teams that so they can test the resiliency of their applications without having to have like root access to everything.
Cool. Let's see.
Looks like there's stuff in Q&A as well. See yours.
Ah, right. Got it.
Oh, yeah, there's a question on similar to auto dependency discovery. Is there any auto health check discovery? There is. We have a thing called intelligent health checks. Today, that's available in AWS. So if your services sit behind a load balancer in AWS, we can use the load balancer to automatically provide you the golden signals for a particular service using the CloudWatch metrics. And that's just like a click of a button. And you can use those to get up and running with services 5-10 minutes.
The way that works is essentially as part of the getting started process, when you log into Gremlin, you have the option of connecting Gremlin to an AWS account. And kind of like Signal was doing, what you do, we're able to see the elastic load balancers that you have running. And if you have the agent running on an EC2 host or EKS host, we're able to correlate those. So we know that the CLB is associated with this service. So that's how we're able to automatically create those health checks for you. All right, cool. Let's see. I don't know if there are any others coming in. So yeah, I will just say, if you think of any other questions that you weren't able to ask or that we weren't able to get to, you're always welcome to reach out to us either right after the webinar or to send us a message at gremlin.com/contact. Oh, one more just popped up. When are you planning to enable auto health check in Azure? The short answer is that it's something that we're looking into. I don't know if we have a concrete date set yet for when we're going to be enabling that, but I believe it'll be hopefully sometime this year, ideally during the summer, that we'll be adding in that functionality. But the best I can say for right now is stay tuned. We'll announce it as soon as we're releasing it or getting close to releasing it. Yeah. Otherwise, if there aren't any questions, again, feel free to reach out to us. We're always more than happy to hear from you. Always happy to answer your questions and provide more information. In the meantime, thanks so much for joining us. Hope this session was helpful for you, and hope you have a great day. Oh, sorry, Dave. I'll drop the link in for you again before I close this out. So that's for annotations. This is for, oh, I'm sorry. There are a couple links on agent resource usage. The getting started compatibility. Oh, really? Oh. All right. Well, the best I can say for now, Dave, is reach out to us afterwards and we'll make sure we get those links to you. I've got them saved separately on a notepad. So if you just shoot us an email or reach out to us through the forum, I'll make sure those get to you. Oh, okay. Or our behind the scenes support person can help us out. Thanks, Kira. Yeah, it might just be Zoom being Zoom, but glad they got to you. All right, everyone. Thanks so much for joining us and hope you have a great Wednesday or Thursday, rather. Excuse me.